and but we'll have sort of an altered version of what you've done the last few days. So we're going to talk about applications and how can we use absolute value functions and piecewise functions in different types of application problems and what kind do they maybe work the best for. So you're looking at modeling the front of a camping tent, and this is the function that you've been given. And so your x and y are measured in feet, and the x-axis represents the ground. So this axis right here is your ground. So we really are looking at things, we really only care about whatever's in this first quadrant right here. So graphing this function, you can look at all the different parts and you should be able to see that you're going to reflect over the x-axis, you're going to translate to the right 2.5 units and up 3.5 units, and that would be measured in feet, and then you're going to stretch vertically by a factor of 1.4. So the vertex will be at 2.5, 3.5, so somewhere about there, and then you would go to the right 1 unit and down 1 unit, but this time you're going to go down 1.4 because you're stretching it, and so you're going to have something that will mirror on the other side of the axis of symmetry. And then you would go 2 units to the right, and instead of going down 2 units, you're going to go down 2.8. So we're going to go down there as 1 unit, 2 units, and 5 units will take me to here, and I've got 3 more, so somewhere in this neighborhood as well. And I will maybe move that one up just a tiny bit so that it looks a little bit better. And then we're going to match a mirror on this side, so it's going to be right about here. And then you know that you would go, let's see, what is it, 1, 2, 3 units to the right, and you would normally go down 3 units, but you would go down 4.2 units. So you're going to end up with, let's see, that would be 1, 2, 3, and then 4.2 is going to take you somewhere like this. And let's see, that would be again around this spot right here. So now the interesting thing is that this is going to take me below the x-axis, but I will go ahead and work on getting this graphed. So it will start here at the vertex and continue, and start at the vertex and continue. And really, we're going to want to stop right here at the x-axis, whatever that number, whatever that value might be. So now it's asking you to think about the domain and the range. Maybe I'll leave that there so we can think about it. So the domain and the range, interpret that. What does that mean? Well, really, your domain is that the tent is 5 feet wide, so you're going from 0 to 5, so you want your domain to be from 0, let's change the size, the font on that, so from 0 to 5, and you're going to want that to be included, so we're going to just kind of put a little, oops, I'll get a little blue arrow underneath from 0 to 5, and that would be included. So, and your range then would sort of be the same sort of dilemma here, or not dilemma, but you don't want to talk about a negative height for the tent. So you want just those positive numbers. So your y is going to range from, let's see, we'll just maybe copy this, it'd be easiest to just do that. So your range will go from 0, but instead of to 5, we're going to change this to 3.5. So that would be your domain and range on that one. So the tent would be about 5 feet wide and 3.5 feet tall. All right, so next, you've got a musical group's new single is released, weekly sales in thousands, S in thousands, increases steadily for a while and then decreases as given by this function. So notice it does have a negative in front of it, so it's going to open upside down. And T is the time in weeks. So really should label your axes here, and in doing so, we're going to put on this axis. So if the scale is 5, this is going to be sales in the thousands, and you really could just put, whoops, 1 and 1, in thousands. And so I'm going to change the size of this font in just a second. And then this would be the number of weeks. So this would be week number, whatever it might be. So you can say number of weeks or week number in that one. So now that everybody understands what each of these axes are representing, then you can go about making sense of this problem. So again, we only want to look at what's in this first quadrant here. So to graph this function, you got all the things. You're going to reflect over the x-axis. Your vertex is translated to the right 20 units and then up 40 units. So we're going to make a little dot right here, and then vertically stretch by a factor of 2. So if we're going to plot this one, then we're looking at placing your vertex is going to be at 20, 40. So at 20 weeks, there will be 40,000 of these sold. So now graphing this, you want to, let's make this a little bit smaller because the graph isn't that big. So we take this and we can clone it infinitely. So you would normally go to the right 1 and down 1, but because you have that 2 there, you're going to end up going down 2 units. So we'll go here. And then again, mirror that on the other side. And you go to the left rather 2, and we would normally go down 2 units, but you're going to go down 4 units because you're multiplying that by 2, and so on and so forth until you can, if you want to, now, you could decide, does it make sense to go past the x-axis, or does it make sense to stop at the x-axis? And this is one of those questions that you need to think about and say, well, in the context of the problem, what is it that I am looking at? Is it feasible to have a negative on either one of these axes? So once you have that figured out, then you can decide that you are looking for the maximum number of singles sold in 1 week. Well, that's going to be that vertex, or the maximum amount. So you would sell at about 20 weeks out, you'd sell somewhere around 40,000 singles. So problem number 3, you're sitting on a boat in a lake and you're going to get a sunburn from the sunlight, and you're going to get it from 2 different places. One, the sun that hits you directly, and some sunlight that hits off the water. So we're supposed to write and graph a function that shows the point of sunlight. So remember, we did this just kind of briefly with the quadratics. If we're going to, you've got 2 points really. You have the minimum, and because if you think about, the sun's going to come down somehow and then bounce back up to hit you. So we've got this minimum at 2.0 and another point at 3.5, and you're going to use that in the in this function, in the absolute value of the general form. So if I take that and I plug in the f of x and the x, so in other words the y and the x, you could see here where I've put in the vertex, and then simplifying that 3.15 minus 2, I get a positive 1.5. Well, and since I'm only going to be working in this first quadrant, I want to make sure that, so let's see, a scale of a half. So that would be 1 and 2, so 2, 0 would go here, and then 3.5, there would be 3.5, and then 1, 2, and 3. So my scale is a half here. So this right here is the reflection point. That's where it hits the water. It's going to bounce up and hit you. So really, again, you have your graph, and it should, let's see what the A is going to be. So now this is going to be positive right now. If I'm putting in this 3.5, or if I'm putting in this 2 here as well, I'm going to keep a positive, so I don't have to worry about the other half of that. So 3 divided by 1.5 is going to give me 2. So the function should be, maybe I didn't write that one down, should be this here, and it will become, let's see, your A will be a 2, and your H will be a 2 as well, different 2's, and then you don't have a K because it's 0. So this is what your function will look like, and when graphing that, it's going to look like this. Now it kind of depends on which way you want to think about it, but probably want to put some points on here next instead. So let's do that. We're going to go to the left 1 and up 2, so we've got that vertical stretch, and left 1 or left 2 and up 4, and right 2 and or right 1 and up 2, and right 2 and up 4, and notice how nicely that's going to fit right in with that other point that's there. So I think what I'll do is we'll not worry about putting any arrows on anything, but if you think about it, the sun really is going to be coming down in this direction towards the water and then bounce back up and hit you at this point here.